And if your differential equation the coefficient of a and b will also be the function of x, y, and z, then this is your quasi-linear first order differential equation. Okay, so this is x, y, z, del z over del y, that is c of x, y, z. So this is a quasi-linear partial differential equation. Okay, so basically, if you check that if this a and b are only function of x and y, then this quasi-linear differential equation reduces to a semi-linear partial differential equation. And if this c x y z, this is equals to the same as the following initial value problem, and that problem is del z over del y and plus c del z over del x, that equals to 0. Okay, so this is your partial differential equation, and here the initial condition are given. Suppose this is x and y equals to 0. This is any function x. Okay, suppose this is equation number. Okay, suppose we take a. Okay, so where this fx is given, this is given function of x, any function, and what is c here? To say c is constant here. Okay, so we take this type of problem and try to find what is the parametric solution of this initial value problem, and what is the finally we reduce that parametric form in the form of xy, and then find division. First step is we have to find the characteristics curves. So first step is we have to finding. Okay, so we write here what is step first. So here in step 1, you have to finding characteristics curves, and for that we have to apply the characteristics. Okay, so this is method of characteristics, that is parameterize the initial curve, that is C, as follows. Okay, so here we have take this this initial condition, that is if we take x equals to say general say s, okay, and we take another variable s, and then y equals to 0 here, so y equals to 0, then what is your z here? So z is equals to, when this is equals to s and this is 0, so this is equals to f of, this is function of fs. Okay, so this is equation number from, so this is a, so we write this is a1. Okay, and if we comparing, this is if we comparing this equation, above equation is a1. Okay, so if you're comparing equation, your main equation, this is a general form of linear first order partial differential equation, and this equation a, so this equation a. Okay, if we now comparing these two, so we get what is the value of a here? Okay, so what is the value of a? A is basically the coefficient of this del z over del x. Okay, so what is the general form of your first order differential equation? This is del z over del x plus b of xy del z over del y. Okay, and then plus of c of any function x of yz into multiplication of z, and that equals to d of xy. So this is linear partial differential equation, and we assign that equation by star. Okay, so if we're comparing that equation, so we get here what is the value of coefficient of this del z over del x. Del z over del x coefficient is only constant c. So here our axy that equals to constant c. What is the b component dxy, that is the coefficient of that equals to 1. Okay, and what is the cxy? This is missing here because no xy into z component are there, and of course this is equal to 0. This is a d of xy that equals to 0. Okay, so suppose these are the equations. So here these values we assign that is equation 2. Okay, so the family of this characteristic curves, and that curves is denoted by x, which is function of say parameter s and t, and we have to find what is the value of this xy in terms of that parameter st. Okay, so these are determined for determined by these are determined by the formula by the okay, so by solving the ordinary differential equation, this is we can get this by solving the ordinary differential equations, and that equations are already you have find in notes. You can take this d by dt of this x, this is of st, this is equals to coefficient axy. Okay, so and this thing. Okay, so you have to solve this equation, and here a of xy that equals to c here. Okay, and second one, what is the dy over this ordinary differential equation dt of this y of st, this equals to the coefficient b. Okay, and here b is equals to 1. So you have to solve this equation and try to find the solution of this x in terms of st here, and here it's y in terms of xt here. Okay, so okay, so
सर
here this is
यहाँ पे
Mhm.
आपने जो dy अपॉन dt लिखा है वो मल्टीप्लाई हुआ है कि वहाँ पे ऑपरेटर है?
This is operator.
सर
The d
वो
by
जो dy
d
अपॉन dt आपने लिखे हैं तो सर वो ऑपरेट सर वो x
d
के लिए
by dt
ऑपरेटर
of
तो क्या
x.
सर y के लिए मल्टीप्लिकेशन कि वहाँ पे भी मतलब
हाँ, मल्टीप्लिकेशन का है।
नहीं सर मैं सेकेंड टर्म में बात कर रहा हूँ वहाँ पे
वो गड़बड़ है। ओके।
सर बस उसी जगह है।
ओके, समझ गया। ये वाई हमने लिख दिया ना, ये गड़बड़ कर दिया। ओके, क्योंकि थोड़ा फास्ट हो जाते हैं ड्यू टू टाइम लिमिट्स, हाँ, तो इसलिए गड़बड़ हो जाती है जल्दीबाजी में। सोचते हैं कितना ज्यादा हो जाए। ठीक है, तो डी बाई डी टी ऑफ दिस वाई ऑफ, तो डी बाई डी टी ऑफ दैट, तो दिस इज बेसिकली ऑपरेटर। और ये चीजें आप जो हमने नोट्स दिया है उसमें आप देखेंगे तो ये चीजें वहाँ पे साइन की है, वहाँ पे आपने लेके चला है। ओके, तो यहाँ पे हम दोनों सॉल्व करें और ट्राई टू फाइंड द सोल्यूशन ऑफ दैट। तो यहाँ पे हम देखेंगे तो दिस इज डी बाई डी टी, दिस इज टी के रेस्पेक्ट में आप इंटीग्रेट कर रहे हो, यहाँ सी कांस्टेंट है, तो इसका जो सोल्यूशन होगा, तो सोल्यूशन ऑफ दिस इक्वेशन दिस इज एक्स ऑफ एस टी, we integrate this is with respect to t here, so this is c with a constant, this is c and t, c of t, okay, plus some integration constant, and that constant here, that constant is suppose c1, but that c1 is the function of not t, because अगर वो t का होगा तो फिर तो आप उसके साथ आप वो constant कैसे कहेंगे आप, तो that constant, this is the function of that s, okay, so this is the function of s only, okay. So similarly here, if we integrate this term, so you can find what is the value of y of st. This is if you integrate that term, so this is basically this one का integration किया तो simply t plus constant, and that constant is the function of that another variable. This is s. Okay, so this is your general solution of this term and this term. Okay, so this is your step first. This is step first. You have to find the characteristics curve. This is xt and this is of yxt. The second step is we have to apply the initial conditions. We have to apply initial condition and then find this value of c1 and c2. Then what is the value of x and y in terms of xt? Okay, so in next page in step 2. So step 2, okay, and step 2 you have to applying initial conditions. Okay, that is okay. So here uh, we're using the initial condition, and that initial conditions are x when t equals to 0, x when t equals to 0, this equals to s, and y when t equals to 0, that equals to 0. ओके, तो ये इनिशियल कंडीशन कहाँ से मिली आपको? ये इनिशियल कंडीशन आपके पास यहाँ गिवन है, दैट इज z ऑफ x 0. ओके, this is your initial condition. So initially this x co or this component is y. This is for x and this is for y. Okay, because z of x y. Okay, so from if we compare this, so see this is for x and this is for y. Okay, so this y is 0 and this x is equals to x. Okay, so here this is a function of your s and t, and where t equals to 0, then t equals to 0, you can find this x is same as s, and here this y becomes, this y component is 0. Okay, so here we, if you're using this initial condition, and our solution is x of st, our solution is x of st, that equals to ct plus c1 of s. When we put in here t equals to 0 here, and s equals to 0, so this implies x of this 0, that equals to c into 0 plus c1 s. Okay, so this equals to this implies what is the value of that? That equals to s, and this equals to 0, and this equals to c1s. C1s equals to this thing. Okay, and here what is the value of y of st? This equals to t plus c2s. So this implies y of s0, this equals to 0 plus c2 s. So this implies what is the value of to c2s. Okay, so from using these two, we can find what is the value of x of st. This becomes ct plus c1s, and what is the c1s is equals to s. So this is the value of that. And what is your y of st? This equals to t plus c2s. What is c2 is 0. So this becomes only t here. Okay, and suppose this is equation A3. Okay, so next step is step 3. And what is step 3 is we have to write in the parametric form of the solution. Okay, 5 star and 6 star, and we have to find the solution in the parametric form. Okay, so here from equation, basically if you take our A2 equation, where what is what is the value of c of xy, you comparing from equation main equation star. So you have a c component is 0, and also this dxy is also 0. Okay, so this is comes from we comparing equation A, our equation main equation, with the standard form equation star. Okay, so here from equation 5 star, we know that what is the mu t. So what is the mu, which is function of st, is equals to exponential of 0 to t our c component, this function of st, and this is dt. Okay, so you can write this 0 to t, so you can write here this is tau. Okay, and this is d tau. Okay, and this thing c of this component that equals to 0, so this is 0, so and integrate that, so you can find exponential of that is 0, so this becomes exponential of 0, that equals to 1. Okay, so this is your mu t. So since from z, which is a function of x, y, and x is the function of st, so s0, and y is the solution of st, that is s and t is 0. Okay, so this equals to z s, this is the function of z s, and t is 0. And okay, so here we can write okay, तो हम इसे डायरेक्ट ना लिखें, बल्कि हम इसे सॉल्व ही कर दें. Okay, so what is our solution is so from equation 6 star, so from equation 6 star, from 6 star से जाएं, so what is the value of z, z of st? This equals to 1 over mu of st integral, this is the formula, this is mu of st, then d of st and dt, and plus any function of s. This is in formula, that is z0. So z0 means t equals to 0. This is function of only s. Okay, so say any function g. Okay, and here what is the d of st is 0 given. What is the mu of st? You have already find that is equals to 1. Okay, so our value of z of st, so this equals to, if you putting this value, so this value is 1. Okay, if you putting this d value, this is 1, this is 0, the product of that equals to 0, so here no term. Okay, and here this only we can find gs over this mu of st, so this becomes only gs. Okay, so now the solution is z of st, this equals to g of s. Okay, so now what is the equation z of s0? Okay, so in next page, we have to find the value of this parametric form. What is the value of this z of st? Okay, so you will write this thing in next page. You can write okay, so since this z x of s0 this gs. Okay, so okay, so this equals to gs, or you can write this is a function of s. Okay, this is a function of g, or this is function of any function of x. Okay, so here we obtain z of st, this is equals to fs. Okay, so thus the parametric form of the solution of the problem is given by this, you can already find what is the x. This is ct plus s. Okay, what is y? Y is simply t. You can find this by equation a3. This is your equation a3. And here, what is z of st? You can find this is any function of s, either g or s, whatever you want. Okay, so this is your equation a4. Okay, so in this form, you can find the parametric solution of s in term of st, y in term of st, and z in term of this thing. Okay, s and t. Okay, so last step, we have to now the finding the solution. So here we have to expressing this st, because our solution is given in the form of x and y. So we have to find our solution in the form of x and y. Okay, so this is the your parametric solution. And if we have to find the general solution of that in the terms of x and y, so we have to expressing our solution, that is z of s and t, z of st in terms of z of xy. Okay, so how can we solve this? So we have to expressing, we have this equation, this is x and y in terms of ts, so we solve that, and we can solve, express this s and t in terms of x and y. Okay, so we have to expressing this s and t as this is a function of x and y, and t be also a function of x and y. Okay, so this we have from our, this equation is a3. So we have from equation a3, and if we try to solve this, uh, okay, so if we try to solve this by okay, so x equals to ct plus s, and this is y equals to only t. Okay, so if y equals to t, then t equals to y. Okay, so what is t equals to y आ गया यहाँ से इन दोनों को solve करके. Okay, and t equals to y, then x equals to cy plus s, cy plus s. So we have to find the s value. Okay, so we have to find what is s. So s is this x minus ct, and this is c and y. So this is your explicit form. So here we can solve this, and what is the s is this is function of x and y. So this is x minus cy. Okay, and what is t here? T be the also function of x y. So this t is simply y. Okay, so now we now write the solution, the solution in the explicit form, in the explicit form as z of xy, this equals to z of the function of s, and this is xy the function, and this is z is basically function of s and t, and s in the terms of x and y, and t is also function of this x and y. So this equals to z, and here what is the function is x minus cy, and this is y. Okay, so this is z is the function of that, and here what is the z of st? Z of st is simply the function of s only. Okay, so this is the function of, from using a4, this is function of only x minus cy, because this z is function of this thing, so this is equals to function of this thing, and this is your any given function which is defined on already in initial value problem. Okay, so initial condition is given z of this x0, that equals to simply function of x here. Okay, so this means you can find this thing, and this you get from equation a1 and a4. By using that two equations, you can find this thing. Okay, so here clearly, if fx is differentiable function, differentiable, so the solution this z of xy, that equals to f of x minus cy. Okay, this satisfies Basically, this is a solution. This satisfies your given PDE. This is PDE. You're given PDE as well as your initial condition. So you can write PDE as well. You can write as well as your initial condition. Okay. So this is the solution which satisfies this PDE as well as your initial condition. Okay. So इस तरह से आप इसे solve कर सकते हैं. Okay. तो एक एग्जांपल और हम देखें, छोटा एग्जांपल. और यहाँ पर तो क्वेश्चंस हमारे बिल्कुल सिंपल थे. थोड़ा सा कॉम्प्लिकेटेड फॉर्म लें हम और उसको सॉल्व करें. तो नेक्स्ट पेज में हम दूसरा एग्जांपल लेते हैं. ओके. तो you find the parametric form. Find the parametric form of the solution of the problem. And if our problem is minus y, suppose zx plus x, zy, that equals to 0. Okay. And with, this is the problem, with the condition, that is initial condition, the condition given by something s square, that equals to s cube, where s is greater than 0. Okay. So this is your initial condition is given. Okay. Okay. So you have to find the general solution, that is z, in terms of x and y. Okay. And also you have to find what is the parametric solution, means what is the value of z of xt. Okay. So what is the value of s in terms of xt, and y in terms of st, and z in terms of st. And then you have to find what is the solution z in terms of xy. Okay. So here, if we compare our this is equation with our standard equation, then the coefficient of what is the coefficient of x here? The coefficient of x is this is minus y. Okay. So here your e component, that is the component of coefficient of this del z over del x, and this equals to minus y. Okay. And here now, if we compare this equation, so that equals to x. And what is here c? C of xy, that equals to 0. And what is d? D of xy, that equals to 0. If we compare this with the standard form. Okay. So the family of this characteristics curve, this family of that curves, which is x in terms of st and y in terms of st, these are determined by, you know that our two ordinary differential equation. By solving this two differential equation, you know that d by dt, that is of x with respect to this equals to a, and here what is a of xy, and here this xy is equals to minus y. Okay, this is st. Okay, and second one, what is d over dt of your y, this function of st, this is your b xy, and here what is b is simply x, that is function of st. Okay, so here you have to solve this two ordinary differential equation, and then you have find that general solution contains the arbitrary constant, and by using initial condition, we have to eliminate that arbitrary constant. Okay, so with initial condition, and initial conditions are given. What is our condition? This x when s 0, so x component is only this s, this becomes s, and what is our y with these 0, this becomes s square. So this is your initial condition. Okay, so this is the initial conditions given. Okay, so we have to find the general solution of these two system, and then using this initial condition and try to eliminate that constant. Okay, so the general solution of the system is okay. So what is the general solution? So here, look here, this d by dt of x that equals to minus y, and d by dt of that equals to this x of this t. Okay, so here, if we're writing here d by dt of y, and y equals to this y equals to minus of this d by dt of that. So this becomes, this is the minus of d2 by dt square of dx, this equals to x. Okay, so this means this is case of like this x double dot plus x that equals to 0. Okay, so if we know that this roots of that equation is plus minus I, so this is general solution is if we try to solve this x of st. So this is the any constant c1 which is the function of s here, because this is the ordinary differentiation to the t here. This is the cos of t plus C2 as sine of t. Okay, and what is the another one? What is the y of st? So similarly, if we put in here this d of xt, and what is x is d by dt of that. So this becomes a minus of that. So in that case, you find this becomes c1 of s, and this is sine t minus c2 as this equals to cos t, because the sign is changed. Okay, so here, if these two are the solution, these two are the solution of this uh, ordinary differential equation, and then you have to using this initial condition, and if you use condition, we find what is the value of c1. Okay, so if this t equals to 0, this becomes 0, this is 1, so c1 equals to this thing. So here c1 equals to, this is simply s. Okay, and what about c2s? C2s, when we putting t equals to 0, this becomes minus of that, and this is s square here, so this becomes minus of s square. Okay, so here these are the two uh, C1 and C2 by using initial condition. So therefore, the general solution, so we can write the general solution, that is x of st, this equals to C1, that is s cos of t minus s square sine t, and what is y equals to s sine t, and s square, this is becomes plus because minus square, so this equals to cos t. Okay, so this is the s and t. Okay, and here the c of xy and also d of xy, that equals to 0. So we have to find from equation 5 star, we have to find what is the value of mu here. Okay, so in next page we can solve and find what is the value of mu here. So next page, what is the value of mu? So mu, that is your integration constant, that equals to exponential of 0 to t, and that is c of st dt, or s tau t tau, and here this becomes 0, so that's why that equals to 1. Okay, and what is the value of z of st? So this is 1 over mu t. Okay, and this is 0 to t mu of st into d of st dt. Okay, so suppose this is that we can here, this is tau here, this is tau, and this is tau. Okay, and plus any function, and that is function of say gs. Okay, so here this is 1, this is 0, this becomes simply, this is the value of z0. Z0 means any function of s only. Okay, so this is your z0. Okay, so this will t equals to 0 means this is function of s. Okay, so here in view we have z, which is function of st. So we get this z at, this is function of s0 and y at s0. Okay, this is basically Z of this is your initial condition S, and this is X cube, and here we find this is GS. Okay, and from initial condition, this Z of S, this equals to this equals to uh, this equals to this equals to basically X cube. Okay, so GS is X cube here. Okay, so this implies Z of ST. This is uh, okay. So this is X cube here. Okay. So here we can, this is GS, and GS is simply this Z of that. Okay, so this is function of only the Y component is this is X cube here. Okay, so you can write Z of ST is X cube. Okay, so thus
So next class है.
ओके बस हम एक लाइन लिख दे रहे हैं, बस द पैरामेट्रिक फॉर्म of the solution of the problem is given by your xt, this is yt, and this is zxt. Okay, and this is s cos t minus s square sin t, this is s sin t plus s square cos t, and this is x cube. So this is the solution final, and here you can eliminate that term and that find z of xy. Okay, तो ये चीज आप खुद से चेक कर लीजिए. ओके, चलिए आज इतना ही करते हैं, 11 बज गए हैं. ठीक है, मैं आपको हम व्हाट्सएप ग्रुप पे हम उसको भेज देंगे, उसके सोल्यूशन भी भेज देंगे हम, जो कल ग्रीन फंक्शन कराए थे और फाइनल उसका क्या होगा, मेथड्स क्या है. ओके, ठीक, 11 बजे.
थैंक यू सर.
मैं कल भी आपको नोट्स में ना सोच रहा हूँ कि मैं आपको पीडीएफ फाइल उसकी बना करके आपके ग्रुप में मैं भेजता जाऊँ, तो उससे आप उसको करते जाएं, यहाँ हम क्विकली उसको सब डिस्कस कर लेंगे. ओके, थोड़ा टाइम अब कम है तो फटाफट हम लोग नोट्स भेजते जाएंगे और आप उसको करते जाएंगे. थैंक यू.
थैंक यू सर.
थैंक यू सर.